Okay, so we are going to start 8.3, which is the applications of systems of equations into variables. So we will use x and y, and we did before when we translate in 8.1, remember? So we're just continuing and solving for it. Yeah. So let's share the page. So share desktop. And let's get a new section. So 8.3, which is application. All right. So we have number problem, which is generally easy. And we have geometry problems like last time, but there are more. Yeah. So this is the last time that you're going to, and we will finish on Monday. So should we have your test on Wednesday? No, not Thursday, Wednesday. Yeah, Wednesday next week. So anyway, we're going to have a test next Wednesday. Yeah, not Thursday. Too long. Right. Now, let's talk about the number problem, meaning we solved the other ones that we did before. So this is from 8.1. So let's see, from 8.1. Where is it? All right. So A, in problems involving number, or let me just do the total value first, because that's harder. Yeah. So 8.3 is total value problems, so total value and mixture problems, and mixture problems. Okay. So when we say total value, it means there is a total amount and the total value. So it's not just the total value. So what do I mean by that? Let's talk about it. It looks something like this. All right. So Staples recently charged, okay. So number one, Staples recently charged, so this is recently but in a few years ago, charged $3.79 per ream and of regular paper and $5.49 per ream of recycled papers, or paper made from recycled fibers. All right. So how many things happen? How many types of paper we have? Two. What are they? Regular and recycled. Okay. Which one's cheaper? The regular. So last semester, the math department at Eli, spent $582.44 for paper for 116 reams of paper. And then the question is, how many of each type is purchased? All right, 582.44. So let me write it again, 582.44. All right, good. So let's see, what do we know? Do we know the price of each? And we also know the total value and the total amount. So this is amount, this is value, right? So a total value problem, always has, this is called the total value, and this is the total amount. So total value consists of total value and total amount. Are you guys ready? No. Nope. So what's going to happen here? How do we write down the steps? So step 1, we have 2 types of paper. What are they? Regular and recycled. Oh, both starts with R. So we could use X and Y. Yes. Because otherwise, we could use the letters, but both starts with R. So I don't think we can use R and R, right? So X is what? What do you want to call X? This is where we define the variable. What is X equal to? The amount of regular paper. So I'm just going to put the regular paper. How about the Y? The amount of recycled paper. All right. So you have to define the variable, give definition. Now, step 2, we're not going to have a table, so we're just going to skip it. Step 3, the equations. How many equations should we have? How many equations do we have? 2, because I have 2 variables, I need at least 2 equations, right? So what are they? So one of them is the total amount, the other one is the total value. So the first equation always talks about the amount. What is the amount? How do I write the equation about the amount? Yes? Are you guys confused? So let's read this. So you have 2 types of paper. What are the prices? $379 and $549. Okay. And then last semester, what happened? They spent the total value of $582 something for 116 reams of paper. Right? So do I know the total value, the total amount? Do I know how many paper total? Yes. So what's the equation related to that? Huh? What did you say? I can't hear you. Huh? So this is the equation I'm supposed to put paper? I'm asking you what equation should I write? I have 2 equations. What are the equations? So one is related to the amount, the other one is related to the value. So what's the equation related to the amount? What is it? This is very simple. So I'm asking you, what is the equation related to the amount? What is equal to 116? So what is my equation? Yes. X plus Y is equal to 116. Maybe we have to write the whole thing, the amount of regular paper and the amount of recycled paper. Maybe that's easier for you, right? So I know what's equal to 116 is the amount of regular paper and the amount of recycled paper, right? Okay. Now this is talking about the amount. Now let's talk about the value. So how much is each regular paper? Which one? 379. 379. Yes, not 549, right? So 379 regular paper. If I buy 1 ream, how much do I pay? 379. If I buy 2 reams, how much do I pay? 379 times 2. If I buy 10 reams, how much do I pay? Okay, what about if I buy X reams of regular paper? How much do I pay? 379 times X, right? So 3.79 times X plus, what about the value for the recycle? What is the value for recycled paper? 5.49 times Y is equal to 582.44. Yeah. Yes, no? Okay. Now, what do we do? Can we solve it? Yes. So how do we solve it? What's the easiest way? Substitution? Okay, so let's do substitution. How do we use substitution here? So step 4, how do we use substitution here? Solve for Y, okay, in equation 1. So then what do we have? Y is 116 minus X, or negative X plus 116. That's fine. All right, this is equation 3. And then what do? We substitute Y equals to 116 minus X to equation 2. So when we substitute, what do we have? 3.79X plus 5.49Y. Y is 116 minus X is equal to 582.44. All right. So 3.79X plus, what is 5.49 times 116? So let's get the calculator out. All right. So 5.49 times 116 is 636.84 minus 549X is equal to 582.44. All right. Then what should we do? Combine like terms. All right. So 3.79X minus 5.49X is negative 1.7X. And then we will subtract 636.84 from both sides. All right. So what is this equal to? So 582.44 minus 636.84, that gives me negative 54.4, right? Okay, then what? Divide both sides by negative 1.7. Okay, so what is X equal to? So 54.4 divided by 1.7. Oh, divided by 1.7. That gives me negative 32. Oh, positive 32. All right. Yes. Now, what would you do next after we get X equals 32? Plug it into equation 3. Thank you, Brian. Yeah, thank you. Okay, so plug it into the third equation. So I'm going to put it here. So substitute X equals 32 to equation 3. So when we substitute, what we have was Y is 116 minus 32. So Y is, what is 116 minus 32? Yeah, so 84. All right, so this is step 4. Now step 5, you write down your answer. How do you write down your answers? What is it? How do you write down your answers? Yes. Yeah, what's the sentence? What's the sentence, or what's the phrase? Oh, we don't need that. It's too long. So regular paper, how many reams? And then recycled paper, how many reams? That's it. Regular, how many? 32. And then recycle 84.3. Yeah? All right. So you will see this problem again when you get to Math 125. So you might as well learn it now, right? So don't be lazy and think, oh, I don't like word problem. You're going to see this again, the exact same one. Because in Math 125, we do discuss 8.3. So you will see this again. Yeah? Okay. So if you think, oh, I'm not going to do it now, then in Math 125, you will see this again. All right. Okay. So this is called total value problem. Have you seen this before? So what do we know about total value? What is it actually that we know? We will be given the total value and also the total amount. Yeah. Okay, so the next one, you should do it. Give me the equations. Yeah. So let's do the next one. If you can't do it, I'm not going to give you the equations. I'm going to skip it. Yeah. So I will do mixture problems. If you're not trying the next problem, I will skip it. All right. So number 2. So number 2. Okay, so quick copy. Recently charged 49 cents per page for color copies. Maybe this is Kinko's. How much does Kinko's charge for color copies? You know. I don't know. I haven't gone to Kinko's for a while. And 7 cents per page for black and white. Black and white copies. So if Shirley's bill for 90 copies was $11.34. So which one is the total amount and which one is the total value? Total amount is 90 and total value is $11.34. Okay, $11.34. Yes. How many copies of each type were made? So how many copies of each type were made? So that's the question. Yeah. So if Shirley's bill for 90 copies was $11.34, how many copies of each type were made? All right. So you guys think about it. What variables do we want to use first? Step 1. Yes? So tell me, what type of copies do they have? Color and black and white. So I could probably choose C and B, right? C is the number of, or the amount of color copies. Okay, what is B? The number of black and white copies, right? Okay, now step 2, none. Step 3, the equation. So this is where I'm going to wait for you. So I need how many equations here? 2. And 1 will relate to the amount or the number. And what about the other one? Will relate to the value. Yes. Okay, so what is the equation related to the amount? What's equal to 90? C plus D, yes. Yeah, you could write B plus C or C plus D is equal to 90. Good. Yeah. Now, the value. So somebody else. So Salman answered the first question. What about the value? What is the equation related to the value?
Both numbers are going to be in the same equation. Does it matter which one the equation is?
No, it doesn't. Oh, yes. So 0.49C. Okay. Plus 0.07B. That's right. Yes. Good. Does everybody get it? Yeah? Okay. Okay, we're not going to solve it. Yeah, because I think you could solve it, right? Okay, so we will do more and then we will just set up. Yeah. Now, the next one, let me tell you the answers so you could do it at home. So after you finish, then you're going to get a color copies is 12 and black and white copies is 78. Okay. So later on, you could try and then get the C is going to be equal to 12 and the B is equal to 78. All right. Now let's talk about mixture. So mixture problem. All right. Okay. All right. So suppose if I say 90%, so before we mix stuff, we have a solution. So we have a 100-liter solution of alcohol, rubbing alcohol. And then it says that this is 90%, 93%. Okay. So what does it mean? That you have a 100-liter solution of rubbing alcohol and it's 93%. So what does it mean? The rubbing alcohol? You know what the rubbing alcohol is? Yeah. Well, when do you use it? On what? Oh yeah, yeah. To disinfect, right? You guys know. If you have a cut, then you put the rubbing alcohol and then you use it. It is very. You feel something, right? It hurts. Yeah. Did you ever try it?
My mom used to use it when I was young.
Yeah. Yes. So I use rubbing alcohol. Yeah, because it should disinfect the. So you don't have bacteria go inside your blood. Yeah. Now, but what does it mean if we have a 100-liter solution of alcohol? Yes, pure alcohol. So how many liter is pure alcohol? So it just means that you have 93 liter of pure alcohol, right? Okay, and what is the rest? Water. 7 liter of water. All right, so this is 93% alcohol. So that's what it means, yeah. Now, actually, we do not need this strong. Like 80% is good enough, yeah. So 80%, 70% already kills the bacteria. So then they want to dilute the alcohol. And then they add more water to dilute it, or you could mix 2 solutions. But suppose I am mixing 93% alcohol, which you know what it means. So 93% is pure alcohol, and let's just say 70% of pure alcohol. 70. What type of alcohol which you could get? So if you're mixing this, what type of concentration would you be able to get? Can I get a 50% alcohol? No. Can I get 100% of alcohol? No. So what type of, what percent of alcohol, what range of alcohol will I get in the middle? Between what? Yes. So your mixture here, depending on your mixture, will have is between 70% and 93%. All right. Okay. Now my next question is, if I have a 90% alcohol, so if this is what I want, 90% alcohol, and you're mixing these two stuff, 93% and 70%, which one do you put more? So this is what I want. So this is what I need. I need 90% alcohol. And I have these two solutions. Yeah. So my question is, which one do I mix more so that I get 90% alcohol? You mix more 93%. Why is that? Because it has more. It's closer to this 90%. This is closer to 93%. Does it make sense? If I need, so I mix the 93% alcohol more, right? But let's just say I only need probably 75% alcohol. Which one of these two did I mix more? 70%. Yes. Why? Yeah, it's closer to 70%, so it's going to contain mostly of my 70% alcohol. Correct? Okay. So now, let's see. This problem always has table. So we always use table, and the table is only consists of three columns. So the first one to mix, the second one to mix, and the mixture. So your table will have three columns. Yeah. All right. So let's do an example. This is not hard as long as you can do the table. As long as we could write the table and it's not hard. All right. So let's talk about blending coffees. Oh, actually mixing nuts. Do you want to mix nuts? Nuts? Do you guys like nuts? What nuts do you like? Cashews. Cashews are good. Walnuts? How about walnuts? Walnuts are good. Pecans are good. Huh? Yeah. Almonds, pecans, peanuts, macadamia, pistachio. Yeah. Which nut is expensive? Walnuts are expensive. Pistachio. Okay. I don't eat nuts that much, but I like them. You know, when I eat nuts, sometimes it's stuck on my throat. Yes. No, I mean, no, not the big nut, but like after I bite on it, and then sometimes there's a small, yeah, it's stuck here. Yeah. Oh, you do? You get it too? Sometimes, right? And then you have to gargle, and then like yeah, throw the nuts away. So that's the only reason I don't eat nuts. But I like nuts. I like macadamia, by the way. Yeah, yeah. Yeah. Okay. So anyway, let's blend the nuts. Okay. So O nuts. Oh my gosh, it's O nuts. This is the company name. Okay. So O nuts sells pistachio. Do you guys like pistachio? Oh. Yeah. For $6.50 per pound. Actually, how much is pistachio? Yeah, and this one. Yes. Okay. And And almonds are more expensive. I think like the whole almonds are more expensive for $8 per pound. Okay. Yes, per pound. Yes. So peanuts are cheap, right? But almonds and pistachios are expensive. How much of each type? So how much of each type should be mixed to should be used, I'm sorry, not should be mixed, should be used to make a 50-pound mixture that sells for $7.40 per pound. All right. Okay. So do you understand what they're trying to do? So there are two types of nuts, right? What are they? Pistachio and almonds. And why do they want to mix the pistachio and almonds? Because some people might not like to eat almond all the time, pistachio all the time, and it makes it cheaper also, right? Okay. So that's why they want to mix. How about you guys? Do you eat the nuts, mixture of nuts, or do you just want one type of nut? Mixture better? Okay, that's probably why they mix it. Yeah. Now, this is what, when we're talking about the table, this is what I mean. Step 2. Okay. Now, we're going to have 3 headings. So in this case, I'm going to have the 2 things that we mixed, which is pistachio and what? Almonds. That's right. And the last column will be mixture. Right? So pistachio, almond, and mixture. Now, and then on here, the row is always value. So it depends on, I'm sorry, the total. The amount, sorry, not total, but amount. So we're talking about amount. So in this case, this is the number of pounds, right? So sometimes it's the price or amount. And then the value. So the value in this case is what? What are we talking about in this context? About the price, right? Okay. And the last one is the total. So it's always amount, value, and total. But they all relate to the context. So in this case, the amount, the unit is in pounds, price per pound. What about the value? What is the unit in value when we're talking about value here? In dollar? Okay. And the total is just in dollar. Yeah. So value per pound. Value per pound. This is per pound. Value per pound. Right? Because you're talking about pounds, and then value is, the second one is value in dollar per pound. Yeah, because the price each. Now let's fill it up. How much pistachio do I mix? Do I know? No, but we call it P. So P is amount of pistachio that you mix. How about almond? What letter do you want to use? A. So A is the amount of almond that we're mixing. How about the mixture? Do I know how much mixture I want to make? How many pounds? So, oops, I was going to write this down. I have 50 pounds mixture that sells for $7.40 per pound. So the mixture, I know the number of pounds, and that is 50. Are we okay so far? So we don't know the amount of pistachio or almond, but we know the mixture will be 50. Yes? Okay. Now, do I know the value we're talking about in each pound. So for pistachio, how much does it cost? 6.50, 6.5. How about for almond? 8. How about for the mixture? $7.40? Okay, good. Now what about the total? So I'm just going to multiply these, right? Each pound is the total in dollar. So each pound, so we're just going to multiply these. So this is 6.5 times P, and then what is this? 8A. What about this? So 50 times 7.4. So 337? 370? Okay. So you're multiplying basically, right? Okay. Now, what are the equations? And how many? 2, because you have 2 variables. Can we find the equations from the from this? What is it? So P. So again, this is your value. P plus A is 50. Sorry, this is the amount. So again, this is the amount. Right? And the total, what about the total? What is the equation related to the total? 6.5P plus 8A is equal to 370. All right. Yes? Is it easy? So what is important here? The table. Yeah. So remember, the table has 3 columns. The first one is whatever you want to mix, and then the last one is your mixture, right? And it always has amount, value, and then total. All right. Okay, so I guess I'm done. We still have we still have 5 minutes. Should we solve this, or let's just set up a new one? How about that? No, I think you could solve it, right? You cannot? Substitution, elimination. No, let's do another one. I think you could try solving it. Yeah. So the answer is pistachio. Well, that's your job. Pistachio is 20 pounds and almonds is 30 pounds. So if you can't solve it, you need to go to SI today or tomorrow. Yeah. All right. So the next one is catering. All right. So catering. So this is blending chocolate. Okay. So number 2. So Katie's catering is trying to create a candy mixture, well, almost Halloween, that is 25% chocolate. All right. Katie has available mixture that are either 50% chocolate or 10% chocolate. Okay. All right. How much of each type should be mixed to get a 20-pound mixture That is 25% chocolate. So that's the question. All right. Do I need a table here? Yep, because I'm trying to mix, right? Whenever we see mixture, we will start a table. So let's just type down what we know. So what about my table? What type of columns do I have? What is it? 50% chocolate, right? So this is the one that you want to mix. What about the other one? 10% chocolate. And the last one is the mixture. All right. Right. The mixture is how many percent chocolate? 25%. Okay. All right. So now the first one is amount. So what is the unit for my amount in this case? Pounds. Okay. What about the value? What are we talking about here? Related? Are we talking about the price? No, we're talking about what? This content. About what? In percent, yes. And then we talk about the total. The total you just have to multiply, right? Okay. Now, let's talk about 50% chocolate that I want to mix. Do I know how much it is? No, so I will call it this one, both chocolate, so we will use X and Y, right? Okay. What about the mixture? Do I know how many pounds? 20. So do you see how when we organize this, it looks really nice and it's really easy to use? Now let's talk about the percent. 50% chocolate, what do I put here? 50, right? And for the 10%, 10. What about the mixture? 20, 25? Yes. Okay, good. So now, what about the total? We're going to multiply each one of them. So what do I have here? 50x, and the other one? 10y. What about the last one? 25 times 20, which is 500. All right. So this is how it looks like. So X is the amount of 50% chocolate. And then Y is the amount of 10% chocolate. Is that right? Okay. Now, what are the equations? What are my equations here? X plus Y is equal to 20. What else? 50x plus 10y, 500. Yeah. So if you organize it in a table, it's a lot easier, right? Okay. All right. So I'm actually finished with the mixture problem, but I'm not finished with the section. So what homeworks do you on Sunday? 8.2b, right? What about the quiz? Should I open? Okay. Should I reopen the quizzes this weekend? So for how long? Not this weekend? When? After the test? After the test. Okay, after the test. Okay. All right. Yeah. Okay, guys. 8.2b. All right. Yeah, and I think I have a quiz. What quiz was it? 8.2. The last one was what? Yeah. Oh, 3.6, 3.6. I don't have 8.2, 8.3. Okay. All right.
You don't think I can make up that last question?
No.
Mm-hmm.
No. Okay, guys. Have a good weekend. All right. So where is this? Okay. Okay, I am not done with the applications of systems of equations, so we will continue this on Monday.